Hello and welcome to my channel. In this video we will solve problem 7 in exercise 12.1 in 12th class maths. So the seventh problem is minimize and maximize z equal to 5x plus 10y subject to x plus 2y less than or equal to 120, x plus y greater than or equal to 60, x minus 2y greater than or equal to 0, xy greater than or equal to 0. So what we have to do is we have to minimize as well as maximize this objective function subject to these conditions. Okay, so solution. Let us write what is given. So given minimize and maximize z equal to 5x plus 10y subject to the first condition is x plus 2y less than or equal to 120, second is x plus y greater than or equal to 60, and third condition is x minus 2y greater than or equal to 0, and these are non-negative constraints, so that is x y greater than or equal to 0. Okay, now we should consider the first inequality and then further consider the line with respect to the first inequality. So that we will call it as line 1. So that is x plus 2y equal to 120, right? So we will make table for this line. So x and y will be 120 minus x divided by 2, right? So if you put x equal to 0, y is 60, when x is equal to 30, so 20 minus 30 by 2, that is 90 by 2, which is 45. Then if x is equal to 60, so we will get 120 minus 60 by 2, that is 60 by 2, which is 30. So this is our table for line 1. Now line 2 let us consider. So line 2 is corresponding to the second inequality. So x plus y equal to 60, so x and y is 60 minus x. Okay, so when x is 0, y is 60, when x is 30, y is 30, when x is 60, y is 0. Okay, so this is the table 2 for line 2. And line 3, so the equation is x minus 2y equal to 0, x minus 2y equal to 0, that means x is there and y will be x by 2. So when x is 0, y is 0, when x is 20, y is 10, when x is 40, y is 20. Okay, so this is the line 3 table. And line 4, line 5, you know, line 4 is x equal to 0, which is the y axis. Line 5 is y equal to 0, which is x axis. Now let us draw the graph here. So this is the y axis, this is the x axis. So x axis, and this is the y axis. This is the origin. Okay, so let us now take the scale. So this is 10, then this is 20, then 30, then 40, then 50, and then 60. Okay, similarly here 10, then 20, then 30, and 40, 50, 60. Okay, so line 1 we will plot 0, 60 it is first point, 0, 60, then 30, 45, 30, 45, so that is here, then 60, 30, 60, 30. So these 3 points you have to join here like this. Okay, so let us name this line. X plus 2y equal to 120, x plus 2y equal to 120. Okay, so now second line we will plot, that is this 0, 60 first point. So the same point here, 0, 60, 30, 30, 30, 30, 60, 0. So the line will be this. So if we name this line, it is x plus y equal to 60. And third line, that is x minus 2y equal to 0. So first point is 0, 0, then 20, 10, 20, 10 here, and then 40, 20, 40, 20 here. So if we join these 3 points, okay, we'll get this line here. Okay, now let us find the solution region for these 3 lines. So we have to put 0, 0 in the first inequality. So put 0, 0 in the first inequality is x plus 2y less than or equal to 120. So that is 0 plus 2 times 0 less than or equal to 120. So that is nothing but 0 is less than or equal to 120, which is true, right? Therefore the inequality is satisfied and the solution region, and so the solution region is the half plane where 0, 0 lies. Okay, so if you look at the first line, and the solution region is this here where 0, 0 lies. Okay, now let us look at the solution region of the second line. So put 0, 0 in the second inequality, that is x plus y greater than or equal to 60. Okay, so that is 0 plus 0 greater than or equal to 60, that is 0 is greater than or equal to 60, right, is false because 0 is less than 60, not greater than or equal to. So therefore the inequality is satisfied, and so the solution region is the half plane. The inequality is not satisfied. Okay, let us write it properly. So the inequality is not satisfied and the solution region is the half plane where 0, 0 does not lie. So if we look at the solution region, it is this. Okay, now let us look at the solution region of the third line. Now if you look at the third line, this yellow line, it passes through 0, 0, right? So we cannot put the point 0, 0 in the inequality, we have to put some other point. So let us put this point here 30, 10. Okay, so it is below the line, right? This point we will put. So put 30, 10 in which inequality? This one, x minus 2y greater than or equal to 0. So that is 30 minus 2 times 10 greater than or equal to 0, right? That is 30 minus 20 greater than or equal to 0, and so 10 is greater than or equal to 0. So this is true. So therefore the inequality is satisfied, and so the solution region is the half plane where point 30, 10 lies. Okay, so you can see the 30, 10 point is below this line, so the solution region is this. Right, now if we extend this line here, this blue line we will extend the x-axis, right? So you can see that the red line intersects with the x-axis, also the green line. Now if you look at the feasible region, that is the intersection of all the regions, you get this region here. Right, let us name the corner point, so let us call this as A. This point is A, then this point as B, this point as C, and this point as D. Okay, so here the feasible region is A, B, C, D, A, right? So let us find the value of the objective function at the first point A. So at A, what is the point A? It is 60, 0. Okay, so at A 60, 0, what is the objective function? So Z is this 5x plus 10y, so we will get 5 times 60 plus 10 times 0, right? So which is nothing but 300. Then at the second point, that is B, and to find the point B we have to do what? We have to put y equal to 0 in the red line. Okay, to find the point B we have to put y equal to 0 for the red line, because when y will be equal to 0 you will get this point B. Okay, on x-axis always the points are in the form x, 0, right? So let us put y equal to 0, put y equal to 0 in this line, the red line, x plus 2y equal to 120. So that is x plus 2 times 0 equal to 120. So that is x is equal to 120, right? And so therefore the point B is nothing but 120, 0. So 120, 0. So that means Z is equal to 5 times 120 plus 10 times 0, so that will be 600, right? Then at C equal to, now if you look at the point C, it is nothing but 60, 30, you can see 60, 30. Or if you cannot see this, you can find the intersection between the yellow line and the red line. Okay, you will get point C as 60, 30. So at 60, 30 z is equal to 5 times 60 plus 10 times 30, so which is 300 plus 300, it is 600. Okay, now at the point D, you can see it is 40 comma 20. So point D is 40 comma 20, so z is 5 times 40 plus 20 times 20, so which is 200 plus this is 10, so 200 plus 200, that is 400. Now we had to find the maximum as well as minimum, that was the problem. We have to find maximum and minimum of the objective function given the conditions. So you can see that the minimum is 300 and the maximum is this 600. Okay, so maximum z is equal to 600 at 2 points, it is at b 120 comma 0 and c 60 comma 30. And minimum so that is z equal to 300 at point A, which is 60 comma 0. So this is the solution. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.